Hi, I'm Jared Martin, a STLE certified lubrication specialist here on behalf of Royal Purple. I'm here today at the School of Automotive Machinists, one of the most respected schools in motorsports education. At SAM, the instructors and students have already seen the benefits in horsepower improvement using Royal Purple motor oils. The automotive world has long recognized the superiority of synthetic lubricants over conventional motor oils. Today, I'm going to show you how Royal Purple exceeds the film strength of any other synthetic lubricant on the market. The film strength of a lubricant is its ability to withstand the effects of load, speed, and temperature without breaking down. An unbroken film between lubricated surfaces is critical in preventing wear. A common industry test to measure a lubricant's film strength and at which point it fails is the Phalanx test. Today I'm going to use a load test to compare the performance of Royal Purple with two other synthetic oils. This test is designed to measure the load carrying capacity of a film of oil. While it may sound complex, in reality it's pretty simple. The test machine uses a 1/4 horsepower electric motor. On this metal shaft is a race that simulates the moving parts of an engine. The race is lubricated by an oil cup, which provides a protective coating of oil film. The oil cup can be changed, allowing us to test different lubricants. Between each test, races and bearings are cleaned completely to ensure validity. Opposing the race is a lever that is used to mount a bearing. By adding a series of weights, it will increase the load and test how each lubricant performs. Each of these 2-pound weights simulates 75 pounds of load. If the oil doesn't have enough film strength, it will lead to increased friction, heat, and possibly failure. Now, you may have seen a similar looking device known as the one-armed bandit used by other marketers in the industry. This test is quite different and produces significantly more reliable results because the load applied is static. You can find out more about Phalanx test equipment and how it's used in the lubricants industry by visiting the independent website phalanx.com. Now, each bearing will be tested under the same load, allowing us to inspect each bearing afterwards and compare how the different lubricants performed. Following proper test protocols, I'll use digital calipers and measure the scar diameter on each of the bearings. The amount of scarring will show how well the oil performs under load. Now, it's important to take into account both the surface area and the amount of force applied to determine the oil's film strength. For this test, I'm going to test Royal Purple synthetic motor oil against two other synthetic oils labeled simply as A and B. Now, I'm going to begin with sample A, a well-known high-quality synthetic oil. Filling the lubricating cup, I'll place it in position. Turn on the motor and check that there's adequate lubrication to the bearing before the load is applied. Now, a film of oil is the only thing separating the bearing from the race. As weight is added and the load is increased, there's a noticeable strain on the bearing. Now, after the bearing has been completely loaded, I can remove it and see how it held up. Under close examination, the bearing shows a large wear area with a rough texture. Using the digital calipers, the surface area of the scar measures 7.8 millimeters by 4.58 millimeters. Using the Timken load calculation, I can determine that this engine oil has a load carrying capacity of 4,599 psi. Now, before moving on to testing the next sample, I'll completely clean the rotor and replace the bearing with a brand new one. This removes any variables and ensures the accuracy of our results. Using sample B, a synthetic racing oil, we'll load the oil bath again and make sure the race is coated. Duplicating the same amount of load allows me to replicate the exact same test conditions I used for the first sample. Now, racing oils are formulated to withstand dramatically harsher conditions than motor oils used in passenger cars. And this sample appears to have done a bit better, but I can still see a rough textured wear pattern on the bearing. Now, the surface of this bearing measures 5.67 millimeters. By 3.32 millimeters. Now, from this I can calculate that the load carrying capacity of this oil was 10,475 psi, which is more than twice that of our standard synthetic oil. Now, the bottom line here is that when the film strength of the lubricant fails, friction results. And this is what causes wear in your engine and decreases performance. Now we're going to test Royal Purple under the same conditions. Okay, now using a new test bearing, I'll make sure the race is coated and then start applying the load. Under the full load of 5 weights, the bearing is still rotating smoothly. Another performance benefit of Royal Purple is that it leaves a tenacious oil film on any surface. So I can take it a step further and remove the oil supply, simulating a cold start on an engine. Even with no oil supply, the engine can be started fully loaded. Now for the real test. Let's see how this bearing compares to the others. Okay, the Royal Purple bearing measures 3.30 millimeters. By 2.33 millimeters. Okay, from this we can determine that the load carrying capacity of the Royal Purple was 25,636 psi, which is more than twice that of the racing oil and more than 4 times that of the leading synthetic. Now, just by looking at it, you can tell that the size of the wear area on the Royal Purple bearing is smaller and without the scarring of the other 2 bearings. Royal Purple clearly has the highest film strength of any of the synthetic oils I tested today. So what does that mean for the consumer? The advantage of high film strength translates into dramatically reduced wear, more horsepower and torque, improved fuel economy, lower emissions, and longer engine life. It's a difference that you can see and experience in your own vehicle. Hey, thanks for taking the time to listen. To find out more, go to royalpurple.com.